Um, my name is Philip Farah. I'm Vice President of Sales and Strategic Partnerships at IonQ, the leader in quantum computing and quantum networking. And I'm here to talk to you today about quantum economies and ecosystem of innovation and how IonQ is playing into this. I want to first thank you for having me in Korea, at Quantum Korea for the second time, and for the partnership that IonQ has in Korea and the friendships that we have here. Thank you very much. First, a quick word on our mission. Our mission is to build the world's best quantum computers and quantum networks to solve the world's most complex and impactful problems. And note that it's quantum computers and quantum networks, the only company that is pursuing both at the same time and leading in both. When we think about quantum, it's pretty clear that the opportunity is humongous. McKinsey says $1 to $2 trillion in annual economic value that will be created by 2035. And this annual value doesn't come from the manufacturers of equipment. It primarily comes from existing industries that will use quantum to improve their products and services the same way we're seeing today AI permeate all of these industries. At the same time, it's very clear that the value share is not going to be equal among all players. In other words, and I think this is a BCG study, the BCG study shows that when the early adopters, the 10% early adopters, will capture 90% of the value created. Why? Because they would have trained the talent, they would have built the algorithms, and they would have access to the most critical machines and most advanced machines that will make the magic happen. At the same time, when you think about quantum, you think about quantum computing and the risks that quantum computing brings to breaking cryptography. There is a concept of Q-Day. Some people were saying it's in 10, 15 years. What I will show you is that this risk is very real, and it's very real in the next 5 years. So quantum computing is going to create tremendous economic value. But quantum computing can also create risks on cryptography and communications. The good news is that quantum networking is the antidote to this risk, because quantum networking creates unbreakable communications, not because of the strengths of the algorithm, but because of the laws of physics. So with this said, you have a very large opportunity from an economic perspective and job creation. You have risks on the other side, communications and cryptography breaking. What are countries doing? They're all pursuing similar objectives. And these objectives include 3 key components. The first one is sovereignty. As a country, quantum is considered a national security. How do I make sure that if this technology is going to be so impactful on the world, I will not be dependent on a technology that I cannot have access to? And the answer is you need to secure the best systems, either by creating them yourself or by partnering and acquiring these systems and ensuring that the value chain is going to be there when you need it. The second point is from a value creation and economic development, how do I capture this large pie? And the answer is you have to be ready, both in terms of education and people, but also in terms of applications and solutions that have been developed. In our experience, it takes 18 to 24 months to take brilliant AI and machine learning engineers and teach them quantum. It takes 24 months to build applications and iterate on them. And so one has to start ahead of the systems being ready. And then the last thing is on the cybersecurity front, updating and upgrading networks takes time. And so one cannot wait until you hit Q day to start upgrading. One has to start ahead of time. When we talk about time, there is an interesting concept. And I just wanted to put this slide in front of you to share with you how fast time is going to accelerate in quantum and why we have never seen, as a humanity, anything that moves that fast. So if you think about classical at the bottom, we know Moore's law, right? Doubles every 2 years, which is exponential. It's very fast growth. When you think about quantum, it's super exponential. Every time you add a qubit, you double the power of your system. If you look in the rear view mirror, 23 to 25, and I'm using our own roadmap to create those, we're adding a qubit every 10 days, roughly speaking. 25 to 27, and I'll show you the roadmap beyond that, on average, we'll be adding a qubit every 2 hours. 27 to 2030, we'll be adding a qubit on average every minute. This is unbelievably fast. It's like standing on a road or on a curve. No matter where you are on the curve, you look behind you, it seems flat. You look in front of you, it looks like a wall. This is the type of acceleration that we are seeing. It's like taking what would have taken 5 years, what in quantum, would have taken 2 million years at classical speeds to increase the power of the system by the same amount. And so this is, we humans, look at the past and we project linearly to the future. This is going to be super linear. And this should bring a notion of the importance of acceleration and time to everybody's mind. Just very quickly on IonQ, we are a leading company from both quantum networking and quantum computing. On the quantum computing side, we use trapped ions. We were founded, one of our co-founders, Jung-Sang Kim, is a professor, very well known in the United States, from Korean origin, who co-founded the company in 2015. And then the company went public in 2021. And we have accelerated the growth of this company by taking these foundations and adding acquisitions on top of those. Acquisitions on the quantum computing include Oxford Ionics, include memory manufacturing with LightSync, and on the quantum networking, ID Quantique, with my colleagues sitting here in the room, Qubitech, and more recently, we went into space with the satellite company, Capella Space. We will be taking quantum into space. We're located in multiple locations around the world, including South Korea. Very happy to be here, where ID Quantique preceded us, and now through the acquisitions, we're in Korea. Those are some examples of partners and friends we've been working with, from KISTI to Megazone, SK, SKKU, Seoul National University, Hyundai, Ministry of Science, and many more. This is a slide that's really important for us. And what I would like you to look at is the first line is our roadmap up till a couple of months ago. And then the second line is our roadmap that we made public recently, very recently. And you can see the acceleration between the two. And you can also see how aggressive this roadmap is. According to, by the way, we always have beaten our roadmaps. For the past 5 years, whatever roadmap we had, we have over-delivered. What we're looking at is by 2030, 2 million high-quality qubits with 80,000 logical qubits and 10 to the power 12 fidelity, which is 10 to the power minus 12 in fidelity. So those are machines that will be life-changing when you start looking at the scale of what these machines can do. Algorithms will have to follow, programming will have to follow, and chances are we will need AI to program and take advantage of all these machines. So the intersection between quantum and AI is going to be a very strong intersection. If you compare this roadmap to the rest of the industry, we're very proud to say we have the most ambitious roadmap today in the industry. But not only do we have a very ambitious roadmap in the industry, this roadmap is for quantum computing, but what you see at the bottom line is who else is also engaging in quantum networking? And the answer is we're the leader in quantum networking and the only player who's doing both. And when you think about quantum networking, people think security, which is like a huge use case, very important use case, securing your networks. But it also need to think about creating the future quantum internet, and the previous presenter was talking about quantum internet and where this is going, and the use cases that you can only create if you have an entangled network, from connecting computers at a distance to doing blind quantum computing, to connecting to the quantum computers, quantum sensors, and moving the information in a quantum format and processing it on quantum computers. The possibilities are infinite, and we have built the first quantum innovation network in the United States recently in Chattanooga, Tennessee. We also have one of the largest quantum secure networks, 800 kilometers in Korea, built by ID Quantique, that the government is using. So real use cases, real developments that we are leading. If you think about Korea, like what would be the future and the accelerated view of quantum in Korea? It would be a combination of infrastructure, which includes, for example, regional hubs connected through a backbone between each other to form a national network. It would be connecting this network to the satellite. It would be connecting those to quantum computers, could be one or multiple, that are powering the quantum computing world. And on top of this, it's adding development centers where you create applications. It's adding R&D centers. It's adding manufacturing capabilities. And IonQ is positioned to help bring this image to reality. As a matter of fact, I want to take the opportunity today to congratulate Korea on making a major push in quantum computing, where MSIT and NRF have launched an RFP to bring a quantum computer, leading-edge quantum computer into Korea. And today, in the morning, there was an announcement. We want to congratulate our friends and partners at KISTI for winning this RFP, and in doing so, setting the foundations for leading-edge quantum innovation that will use these systems to build applications, increase research, and accelerate quantum transformation in Korea. Congratulations. Finally, how do you put this picture together? I showed you a picture with a map of Korea and the different components. We at IonQ have put this picture together multiple times already. In the US, both in Maryland and in Seattle, we have hubs that include all the different building blocks, from quantum computing, quantum networking, application development hub, R&D and manufacturing. And we've done it in partnership with key labs, national labs, research universities, the private sector, and the public sector. In Switzerland, for some of you who might have heard of Quantum Basel, it's a quantum city in Switzerland on the beautiful Basel River, powered by IonQ computer computers, I should say, 2 back-to-back generations. One already there, the second will be delivered, and an application hub. In Tennessee, USA, I mentioned the first quantum internet system that we have delivered, and that is open to all innovators to come and create applications using our system as the backbone to test the limits of the economy that they can create on a quantum network, on the quantum internet. We also have a quantum computer and an applications hub that we have positions in Tennessee. And finally, South Korea, as I mentioned, very large quantum networking presence with ID Quantique, quantum applications with partners such as Megazone Cloud and Kisti, and looking forward to a push in quantum computing with the new direction that the NRF and MSIT have recently set. So with this said, I want to thank you all for the time. I want to thank you very humbly for the partnership and for the trust that you have put in IonQ. Your trust is in good hands. You're betting on the right partner, and we will make sure that whatever projects we do together will be projects that will benefit Korea. Thank you very much.